Hello to everyone. My name is Adibuddin Ahmed, working as a Assistant Professor, Department of Electrical Engineering in Institute of Engineering Technology, Lucknow. Today, we are going to here to discuss a very important and very essential subject, that is power system protection. And power system protection is very important subject in terms of not your academic subject, but also for your competition point of view. That is very important subject for your competition point of view, for your GATE and other competitive exam. So, that is very important subject. So, let us start with power system protection. So, the pre-requirement of this course is basically the power system 1 and power system 2. So, we need two subjects basically for this subject to understand this subject, and these two subjects is very basic subjects. So, we are not going through the very high knowledge about these two subjects or depth knowledge of these two subjects. So, you have only required basic knowledge of these two subjects. So, the course outcome of these two subjects will be: first course outcome, we have 5 course outcome of these two subjects. So, first course outcome is describe the relay and different protective schemes. Second, explain relay types and different protective schemes, and second course outcome is explain relay types and its application. So, this first and second basically the first introduction and the working of the relay is about the working of the relay. Third course outcome is depending upon the describe the types of the faults and protection scheme for major components of power system. So, these third course outcome is basically depend upon the types of faults and the major scheme to avoid the types of fault, or we can say the control action of to avoid these faults. And fourth and fifth course outcome is depend upon the describe the circuit breakers, operation, testing and types. So, these course outcome dedicated to the circuit breaker and the types of the circuit breaker and the type and the testing of the circuit breaker, because circuit breaker is very important component of the power system protection. And fourth course outcome will depend upon the explain the electronic relay, microprocessor and computer based protection scheme. So, basically the fifth course outcome is depend upon, you can say that the digital protection or digital component of the power system protection. So, the fifth course outcome is depend upon the digital type of protection. So, moving further, we have 5 units in this syllabus or in this subject. So, unit first is depend upon the protection scheme. So, in unit first we will discuss about the need for protection scheme, evolution of protective relays, zone of protection, primary and backup protection, essential qualities and classification of the protection scheme, and automatic relay closing, transformer for protection and potential transformer and current transformer, and the summation transformer. So, these are the main component of unit first. And in unit second, this unit second is depend upon or is basically dedicated to the relays. So, in this unit second we will discuss about the magnetic, electromagnetic, attracted and induction type relay, and thermal relay as gas actuated relay, design consideration of electromagnetic relay, relay application and characteristic, and amplitude and the phase comparison. So, these all about the unit second relay. And if we talking about the second part of the unit second, so this part is dedicated to the static relays. In static relays we will discuss about the comparison with electromagnetic relays, classification and their description over current relays, directional relays, distance relays and differential relays. So, these about the unit 1 and unit 2. Now, we will discuss about the unit third. So, unit third is protection of component. So, in unit third we will discuss about the types and detection of the faults and their effects, alternator protection scheme, stator rotor. So, power transformer protection scheme. So, this unit is dedicated to the basic utility protection, transformer protection, transmission line protection, and what are the different topologies, what are the different types, different type of scheme used to protect the bus bar, used to protect the transmission line, used to protect the transformer. So, this unit is dedicated to that type of protection. And unit 4, that is the circuit breaker. Circuit breaker is very essential, very important component as if you are talking about the protection of the power system. So, unit 4th is dedicated to circuit breaker. Basically, the circuit breakers types, arc, the extension theories, because arc is very extensive phenomena in circuit breaker. So, we have to remove this arc or quench the arc as soon as possible. So, unit 4 is depending upon the circuit breaker component, current chopping, resistance switching, capacitive current interruption, and the interruption of circuit breakers and rating. And the second part of unit 4 will be testing of circuit breakers. So, circuit breaker is very important. So, testing of circuit breakers is also very important. So, unit 4 also having some classification, testing section, equipment testing, protection, direct and indirect testing, and SF6 circuit breaker, basically the description of the different type of circuit breakers, classification of circuit breakers, construction features, operating bulk oil, minimum oil, and air blast or SF6 type of circuit breakers. And the final unit, that is the modern trends in protection. So, this unit is dedicated to the modern trends. So, in this unit we will discuss about the electronic relay, static relays, function circuits, comparators and level detectors, logic and training circuits, microprocessor and computational computer based protection. So, this unit is consist on the basically digital protection type scheme. In this unit we will discuss about some software development, some algorithm of the protection scheme of the digital relays. So, now we will start from the unit first, and the first fundamental topic of the unit first is, that is the introduction of the power system protection. So, we will discuss about what is the introduction of power system. First, the purpose of electronic power system is to operate and supply, is to generate and supply. So, basically we are generating some electrical quantity, and the far end we have some consumers. So, the consumer is ready to consume this electricity or some power. The power system should be designed and managed to deliver this energy to the utilization point of view, both reliability and economically. So, these two terms is very important. First, the system should be more reliable, because system having some very costlier component. So, that I want that the reliability of the system is very high. So, that our main concern is that our system should be reliable, because we are going to connect very costlier equipment on the power system. So, reliability, and second is economically, no one wants to pay more extra money. So, that is why we want some optimized money. So, that is the economically, system should be economically, and the capital investment of the system or power system, if you are talking about the establishment or if you are talking about the capital investment, is very high. So, that we want that these capital investment should not ruin by any type of fault, and the safety of the equipment is very important, and we also want that our equipment will work on the peak efficiency. So, our equipment will work on the highest efficiency. So, that is very important, highest efficiency plus safety. So, and we want that our equipment must be protected from the accidents. So, that is why that is very important. If you are talking about the fault, so we can say that the normal path of the electric current is from the power source through the aluminum conductors, basically from the generators, transformer and the transmission lines, and the load is connected, and the load is confined with the aluminum conductor, generating end and the receiving end. But anyhow, there are some problem. So, the insulation however may be break due to either by the effect of temperature or some aging effect. Maybe the wire is a very ageful wire. So, the time span is very long. So, that the material of that wire is broken or damaged. Some physical accident is always occur. So, that the current follows a abnormal path. The current will not confine through the desired path or through the conductive path. So, that is phenomena known as the short circuit, or that current will known as a short circuit current, or phenomena is known as short circuit or fault. Any abnormal operating state of the power system is known as the fault. So, that is called the fault, and faults generally consist of the short circuit as well as open circuit. There are also fault, you can say the open circuit fault, either the current will not confine the exact path or follow some other abnormal path, you can say this is a short circuit. But also when wire is break, so this condition is also known as the open circuit fault, and open circuit faults is less frequent than the short circuit fault, but open circuit faults occur, and maybe it is possible that open circuit fault converted into short circuit fault in later position. So, these basic condition of the fault, Now, we will discuss about the classification of the switchgear. Switchgear is very important. So, switchgear basically the switching equipment that is used in the power system, switching different type of switching equipment and the supporting equipment that is used for the power system protection. So, if you are talking about the classification of the switchgear, we can classify the switchgear depending upon the voltage value. So, low voltage and switchgear and the high voltage switchgear. So, basically the low voltage switchgear having a some low voltage profile. You can say that this low voltage, or you can say normally the voltage below 33, or you can say the 11 kV. So, and another second end we have a very high voltage like 400 kV or more than the 400 kV. So, these voltage is high voltage category. So, you can classify your switchgear in low voltage and high voltage. High voltage basically used for the transmission, and the low voltage is generally used for the distribution end. So, switches, that is low voltage classification of switchgear. First you can say that is switches, that is the air brake switches. So, first you can say the air brake switches, air brake type, and secondly there is isolator. So, that is basically the isolator. Isolator is a mechanical, you can say the switch that is used to disconnect the system, but isolator having a very different qualities as compared to the circuit breaker. Another is fuses. So, we have different type of fuses. Fuses also a protective scheme or protective method to avoid the system or to avoid the damage of the component. And we have relays. So, relays is very important. Basically, relays is sensing element that is used to sense the fault. If there is a fault, then relay will sense this fault and relay will give signal to the circuit breaker, and circuit breaker will detach or will disconnect the healthy section or faulty section from the healthy section. So, that is why another is circuit breaker. So, circuit breaker is very important, and circuit breaker is also a switch working on very different type of mode. You can operate the circuit breaker manually, or you can circuit breaker by automatically. Automatically circuit breaker will operate when there is a fault. So, this circuit breaker is having some duty to eliminate the faulty section from the healthy section. If you are talking about the high voltage switchgear, so high voltage switchgear having oil switches. We have different type of switches. These all are switches are basic fundamental duty that these switches used to detach or separate the faulty section from the healthy section. So, this is the fundamental duty of the switches. So, we have all oil switches, we have isolators. Isolators both having a different type of rating. One isolator is belong from the high voltage switchgear, and another isolator is depend upon or associated with low voltage switchgear. And we have circuit breaker, low voltage circuit breaker and high voltage circuit breaker, HRC fuse, and we have lighting arresters. HRC fuse is high rupturing capacity fuse. HRC fuse basically a fuse having a some high rupturing capacity. So, high rupturing capacity means that when a fault is occur, these type of switches burn very fast rate. So, that is why that is very high quality switch, HRC switch. Another is lighting arresters. Lighting arresters is used to avoid the surge, or you can say the lightning stroke on the transmission lines. So, to avoid this and to avoid the damage of the transformer from the lightning stroke, we use lighting arresters. Also, we have some current and potential transformer. Current potential transformer, some auxiliary devices, you can supporting devices. These devices is used basically to measure the faulty condition, because we want to measure very high voltage and very high current, and with the normal equipment we are not capable to measure this high voltage and very high current. So, that is why the current and potential transformer lie in the high voltage switchgear. Now, moving further, we will discuss about the need of power system protection. So, basically our second objective or second topic is, that is need for power system protection. Why we are going to protect the power system? That is very main fundamental question, because the objective of the power system is to isolate the faulty section of electrical power system from the rest of the live system that the function satisfactory without any severe damage to the fault current. So, that is very important that we are going to separate the faulty section with the healthy section without any compromise in the continuity of the healthy section, because at the same time we have different type of loads. One load is, for example, here, for example, you can say that this institution having some load. So, this institution is important, but we have some another important purity, like same some hospital is connected with the power system, some army system is connected with power system. So, we have some purities. We do not want that the supply fails occur in the power system or supply failure occur in power system. We do not want, because in hospital, because hospital is very high purity. That is why we want that if a fault occur in this institution, so that this faulty section or this institution will break or will detach from the healthy section, and we are not going to interrupt the supply of the hospital. That is very important. Actually, circuit breakers isolate the faulty system from the rest of the healthy system, and these circuit breakers automatically open during fault condition due to its trip signal, which comes from the protection relays. So, protection relays is there. Protection relay basically sense the fault, and after the sensing the fault, protection relay will give signal to the circuit breaker, and circuit breaker will trip the line or faulty line, so that the faulty line separate from the healthy line. The main philosophy about protection is to that no protection of power system can prevent from flow of fault current through the system. It only can prevent the continuation of the flowing the fault current, quickly disconnect the short circuit path from the system. So, first we are not going to detach or we are not going to stop the faulty current, rather than we are going to stop the faulty current section from the healthy current section, or we are interrupting the continuity of the fault current. We are stopping or we are going to disconnect the faulty section, or we are going to stop the continuity of the faulty section. That is very important. The objectives are neat, or you can say that these are the main motivation, or these are the main objectives, these are the main needs for the protection of the power system, because power system having consists of very high costly equipment. So, we want to save this equipment, and we want some continuity problems, because in power system there are different type of electrical equipment connected to for life savior as compared to for example, if you are talking about the hospitals, the hospital having some different type of equipment, and these different type of equipments is serving as a life saver. So, that is why we are going to we does not allow to interrupt the supply of the hospital. So, that is why this is the main objective of the power system, to protect the equipment, to protect the system if there is a fault occur at any point of the power system. So, we does not want to spread the fault from healthy section or from faulty section to the healthy section. We want to just as quickly as possible eliminate the faulty section from the healthy section. Now, next topic, the important elements of the power system protection. So, the important elements of power system protection, first basically the strong, or we can say that the main component of the protection of power system is we can say the circuit breaker, although there are some other component, but the main important component, that is circuit breaker, because circuit breaker is responsible to detach or to separate the faulty section from the healthy section. So, we have a different type of circuit breakers: bulk oil circuit breakers, minimum oil circuit breakers, SF6 circuit breakers, air blast circuit breakers, and vacuum circuit breakers. So, these are the different type of circuit breakers that are used for protection of the power system. Different operating mechanisms such solenoid, spring, pneumatic, hydraulic, etc., are used in the circuit breaker. So, these are the all are the different type of mechanism, and based on the mechanism the circuit breaker quality, circuit breaker rating also different. different circuit breaker having some different rating, some different qualities depending upon the mechanism that is used in the circuit breaker. Circuit breaker is the main part of the protection system in the power system, and it is automatically isolated the faulty portion from the system by opening its contact. So, the main elements of the power system protections are here. We can say the main elements are, one is circuit breaker, that is important element. Another element is transducer, and third element is protective relays. We will discuss one by one the circuit breakers, transducers and protective relays. So, let us start with circuit breaker. Circuit breaker is a mechanical device that is used to energize, interrupt and electric circuit. So, circuit breaker is basically a mechanical device. Why circuit breaker is mechanical device? Because circuit breaker having some contact, and these contacts are connecting and disconnecting, and these phenomena based on some electromechanical or mechanical system. That is why it is called the electromechanical device, and it should be able to open and close quickly, maybe in order to few milliseconds. Circuit breaker having a quality that it can able to open and close very fast. So, that very fast circuit breaker we want, or we desire that we have very fast circuit breakers, very fast operating circuit breakers, so that the less time required to separate the faulty section from the healthy section. It should be able to carry the rated current continuously and at nominal voltage. So, the power rating or current and voltage rating of circuit breaker is very important, because the current and the voltage rating is continuously withstand by the circuit breaker, and also circuit breaker withstand the large short circuit voltage and you can say the large short circuit current. So, sometimes a momentary current, or you can say the transient current, its current value is very high. So, that the during the first 5 cycle after a fault, the current value is very large, you can say the 10 times or 20 times more than the operating current. So, that is you can say the transient current. So, circuit breaker must also having some property to bear this high value of current also, although this high value of current is momentary, or you can say the some transient current. Example, these are the some transient current, but these transients, that high value, that is a peak value, is very high. So, that circuit breaker should withstand this value. The circuit breaker must be able to interrupt a large short circuit current called the interrupting rating. So, circuit breaker if capable to interrupt the large short circuit current, so that is we call the circuit breaker having a high interrupting rating. Also, when the current carrying contacts of the circuit breakers are opened, the electric field appears across the contacts that ionize the medium between them, and arc is established between the contacts. So, the arcing phenomena is very important, or you can say that very wide phenomena, because when a circuit breaker interrupt the value of current, the ionization take place between the medium of the circuit breaker, and because of that medium a arc is produced, and this arc will continue the supply through this medium. Contact is breaked, contact is now detached or move away, but still the continuity of the current is also take place. You can understand that these are the contacts, but and these are the two contacts, we have some gap between these two contacts, but also we have no physical connection, but also we have some arcing connection, and this is called the arc, and this is arc is also that is electrically connection, not conductive connection, but you can say that some ionizing connection. So, this is arc. The circuit breaker must be able to extinguish or interrupt this arc as quickly as possible, and this arc is not very desirable. So, we want that we will distinguish or we will vanish this arc, we will remove this arc as quick as possible, and removing this arc is called the quenching process, or you can say that the extinguishing process. And how we can remove this arc? By elongating the contacts. By elongating the contacts, so we will remove this arc, because after the or you can say the elongating the contacts, the arc also elongate. That is why the arc going to weak. And cooling the arc, so we can also cool this arc. So by the help of some cooling mechanism, we can cool this arc, so that also this arc will going to weak. And this will occur when our current is going to zero passing condition. For example, alternating current is like that. So this is a condition for zero passing. At zero passing condition, the current is 0. So that at this point, we will extinguish, or we will going to extinguish our arc at this point, on that point, because at this point the current value, let us suppose this is a current, this is a time. So this at this point the current is going to positive edge to negative edge. So the magnitude of this current is 0 at this point. Some different type of technologies are used for the arc quenching. One of the leading technology, or one of the good technology, is vacuum type circuit breaker, or some extinguishing medium like that SF6. So we have some SF6, that is sulfur hexachloride SF6 medium. This is very good medium. Also we have air and oil also having medium. This medium is used to extinguishing the arc, because we want to extinguishing the arc as quickly as possible. So that we want to recondition our medium between the contacts, and this medium will expose by oil, air, sulfur hexafluoride, or some vacuum, not the common air. That is why we are going to quench this arc. So we have different type of circuit breakers. So in next lecture we will discuss about the another main component of the power system in our next lecture. Thank you so much.